So, we are starting regarding the heat part today, okay, and including the temperature part, okay, fine. As we all know very well that heat is a form of energy which flows from a bodies of high temperature to body of low temperature, okay, and the temperature is defined as it is the relative degree of hotness or coldness of a body. It decides the direction of heat flow when bodies are in thermal contact. To measure temperature, we need a thermometer. Usually, melting point of ice is taken as lower fixed point. We write it as LFP, lower fixed point LFP, and the boiling point of water is taken as upper fixed point UFP. Okay. The distance between lower fixed point and the upper fixed point is called fundamental interval. Okay. And fundamental interval is given as upper fixed point minus lower fixed point. The fundamental interval is divided into equal parts. These equal parts are given arbitrary numerical values of temperature known as thermometric scale. The various scales of thermometer are, okay, we have got Celsius scale, Fahrenheit scale, Reaumur scale and Kelvin scale. In Celsius scale, lower fixed point is 0 degrees Celsius, upper fixed point is 100 degrees Celsius and the total number of divisions are 100. Okay. Now, in Fahrenheit scale, the lower fixed point is 32, upper fixed point is 212 and the total number of divisions are 180. Okay. In Reaumur scale, the lower fixed point is 0, the upper fixed point is 80 and total number of divisions are 80. Whereas, in the case of Kelvin scale, lower fixed point is 273 Kelvin, upper fixed point is 373 Kelvin and the total number of divisions are 100. Okay. Now, let us try to obtain the relation between the various scales. Okay. Let us try to find out the relation between Celsius scale and the Fahrenheit scale. Consider a trough containing the ice, okay, which is at 0 degrees Celsius. Let us now consider two glass tubes in which mercury is existing, and these two glass tubes are kept into the ice container. Initially, when the glass tubes are placed in the ice container, the mercury level stands at certain height. Okay. In one glass tube, the mercury level is named as 0 degrees Celsius. In other glass tube, the mercury level is taken as 32 degree Fahrenheit. Gradually, the ice is heated, okay, and it is converted into water. Still continuing the heat part, the water comes to the boiling stage. When the water is boiling, the mercury in the glass tubes has attained a height, certain height. In the first tube, that height is named as 100 degrees Celsius. In the second tube, that height is named as 212 degree Fahrenheit. So, in the first tube, the distance between 0 and 100 is 100 divisions. Okay. And in the second tube, the distance between 32 and 212 is 180 divisions. So, in this glass tube, the 100 divisions are made, okay, and in this glass tube, 180 divisions are made. So, from this what we can say is 100 divisions on Celsius scale is equals to 180 divisions on Fahrenheit scale. So, 1 division on Celsius scale becomes now 180 by 100 divisions on F scale. Now, let us consider some C divisions on Celsius scale. which is F minus 32 divisions on Fahrenheit scale. So, C divisions on Celsius scale is 180 by 100 into C divisions on F scale. But C divisions on Celsius scale is equals to F minus 32 divisions on Fahrenheit scale. So, C divisions on Celsius scale is replaced by F minus 32 divisions on Fahrenheit scale. So, F minus 32 is equals to 180 by 100 into C. This we can write as C by 100 is equals to F minus 32 by 180. This is nothing but C minus 0 degrees by 100 minus 0 is equals to F minus 32 by 212 minus 32. So, here we observe that reading minus lower fixed point divided by upper fixed point minus lower fixed point. In this manner, we are getting a formula as, by using the formula reading minus lower fixed point divided by upper fixed point minus lower fixed point, let us establish the relation between all the scales. Okay, fine. Like in Celsius scale, we have got C minus 0 by 100 minus 0, whereas in the case of Fahrenheit, we have F minus 32 divided by 212 minus 32. It is also equals to the Reaumur scale R minus 0 by 80 minus 0. Now, in the case of Kelvin scale, what we have got is K minus 273 divided by 373 minus 273. In the same manner, reading minus lower fixed point is equal by upper fixed point minus lower fixed point. This entire equation, set of equation can be given as C by 100 is equals to F minus 32 by 180 is equals to R by 80 equals to K minus 273 by 100 equals to reading minus LFP by UFP minus LFP. Let us compare C by 100 with Kelvin scale. What we are having is C by 100 is equals to K minus 273 by 100. From this we can obtain as C is equals to K minus 273 and K is equals to C plus 273. If we are having a Celsius scale, then to convert it into Kelvin scale, we need to add 273 to Celsius scale value. Then we are able to get the Kelvin scale value. Okay. Now, let us try to understand regarding the temperature difference on different scales. For example, let us say C1 is the measurement on Celsius scale, F1 is the measurement on Fahrenheit scale, R1 is the measurement on Reaumur scale, and K1 is the measurement on Kelvin scale. In such case, we can write it as C1 by 100 is equals to F1 minus 32 by 180 equals to R1 by 80, it is equal to K1 minus 273 by 100. Okay. In the same manner, we are having C2 on Celsius scale, F2 on Fahrenheit scale, R2 on Reaumur scale, and K2 on Kelvin scale. Then we can write it as C2 by 100 equals to F2 minus 32 by 180 equals to R2 by 80 equals to K2 minus 273 by 100. Okay. Let us subtract one from the other. Then we have got C2 minus C1 by 100 equals to F2 minus F1 by 180 equal to R2 minus R1 by 80. It is equal to K2 minus K1 by 100. This we can represent as delta C by 100 because C2 minus C1 is a change. So, C2 minus C1 can be given as delta C. In the same manner, delta F by 180 is equals to delta R by 80 equal to delta K by 100. Okay. Now, let us see a model. At what temperature is the Fahrenheit scale reading equal to half that on the Celsius scale? And the options given for us are minus 14.6, minus 18.6, minus 22.6 and minus 24.6. Okay. Let us try to solve the problem right now. Okay. Now, in the problem it is given very clear that Fahrenheit scale reading equal to half that on the Celsius scale. It is clearly given that F is equals to C by 2. Now, let us consider the formula. C by 100 is equals to F minus 32 by 180. In simple manner, what we do here is, in the place of C we can write 2F. So, 2F by 100 is equals to F minus 32 by 180. Okay, fine. Now, from this what we are able to get is zeros gets cancelled off, and here we are getting 2 5s, 2 9s, and we cross multiply it. Okay, 18F is equals to 5F minus, okay, 5 2s are 10, 1, 15 plus 1 16, 160. Okay, bringing this 5F this side, 18F minus 5F is equals to minus 160, and we are having 13F is equals to minus 160 and F is equals to minus 160 by 13. On dividing minus 160 by 13, we get F is equals to minus 12.3. Just substitute in the value of F, we get minus 12.3 is equals to C by 2, okay, and C is given as minus 24.6, which is our fourth option. Okay. Now, let us consider another model. Okay, fine. What is the temperature for which the reading on the Kelvin and Fahrenheit scales are same? The options given are 374.6 degree Fahrenheit, 474.6 degree Fahrenheit, 574.6 degree Fahrenheit and 674.6 degree Fahrenheit. Okay, fine. For this problem, we consider the formula as K minus 273 divided by 100 is equals to F minus 32 by 180. In the problem, Kelvin and Fahrenheit scales are having same value. In such case, we can write here K equal to F equals to X. Okay, fine. Then we are going to have it as X minus 273 by 100 is equals to X minus 32 by 180. On simplifying this, we get X is equals to 574.6 degree Fahrenheit, or it can be the Kelvin. Anyway, we can write it as. Thank you. Now, let us consider another model. Okay, fine. A mercury thermometer is transferred from melting ice to a hot liquid. The mercury rises to 9 by 10 of the distance between the two fixed points. Find the temperature of the liquid in Fahrenheit scale. We know very well that in Fahrenheit scale, the total number of divisions are 180, and we are given the mercury rises to 9 by 10 of the distance. So, 9 by 10 of 180 divisions is given as 162. But we all know that the Fahrenheit scale starts from 32 onwards. Therefore, our solution will be 32 plus 162, which is given as 194 degree Fahrenheit, which is our first option. Now, let us consider the principle of thermometry. Okay, fine. Let us say a physical quantity as x and T as the temperature. Here, the physical property x is linearly varying with temperature. We are having a linear graph here. Okay, fine. And the physical property x is related to temperature as x is equals to AT plus B. Okay. From this equation, we obtain a relation between x and t as T by 100 is equals to xt minus x naught by x 100 minus x naught. Now, let us consider a model upon this property. Okay, fine. What we have got here is the readings corresponding to the ice point and the steam point for a constant pressure gas thermometer are 500 cubic centimeters and 545 cubic centimeters. If the reading corresponding to room temperature is 510 cubic centimeters, then the room temperature will be, the values given are 22.22 degrees Celsius, 32.22 degrees Celsius, 42.22 degrees Celsius and 52.22 degrees Celsius. Just now we have related the physical property with the temperature. Just now we have related the physical property with the temperature as T by 100 is equals to xt minus x naught by x 100 minus x naught. Here the physical property is volume, and here we are observing the changes in volume with the change in temperature, and the pressure remains constant here. So, the formula can be rewritten as T by 100 is equals to Vt minus V naught by V100 minus V naught. Now, substituting the values, we have got T by 100 equals to Vt is 510 point minus V naught is given as 500 and V100 is given as 545, 545 minus 500. On simplifying this equation, we obtain T is equals to 22.22 degrees Celsius. In the previous case, we have considered the volume as the physical property. Okay. The same manner, we can write the physical property, we can take the physical property as resistance, and also we can take the physical property as pressure and other things. In that manner, what we have the equations as T by 100 is equals to Pt minus P naught by P100 minus P naught. Similarly, T by 100 is equals to RT minus R naught by R100 minus R naught. The same can be written for T by 100 equals to LT minus L naught by L100 minus L naught. In each case, we are having here the pressure as physical property, here resistance as physical property, here length as the physical property. The same manner of substituting the values, we can obtain various types of problems. Now, let us try to have another model here. Okay. We are trying to understand from the graph right now. Okay. The graph shows the relation between centigrade and Fahrenheit scale of temperature, and we are asked to find the slope of the graph. Okay, fine. Usually, whenever we are given such problems, okay, what people usually do here is they will try to go with slope m is equals to tan theta, and tan theta is opposite by adjacent, and taking the values from the graph, and they will try to do this model. But instead of that, what we can have here is, okay, we know the formula C by 100 is equals to F minus 32 by 180. From this we can write as F minus 32 is equals to 180 by 100 into C. This we can write it as F minus 32 is equals to 9C by 5. Okay? And we write this as F equals to 9C by 5 plus 32. It is a sort of linear equation. It is in the form of y equals to mx plus c. The constant value, that is y intercept, is 32, which is here, okay, and the slope value is given as m equals to 9 by 5. So, without touching the graphical part, just by using the formula part, we are able to say the slope of the graph. So, the slope of the graph between centigrade and Fahrenheit scale is given as 9 by 5. Now, let us go for another model here. Okay, fine. What we say here is, two absolute scales x and y have triple point of water defined 300x and 450y. The relation between Tx and Ty are, the options given are Tx is equals to 1 by 3 Ty, Tx is equals to 2 by 3 Ty, Tx is equals to Ty, and Tx is equals to 4 by 3 Ty. We know very well that on Kelvin scale, the triple point of water is given as 273.16. Okay? So, having the relations for k, x and y, we represent as, in k we write 273.16, in x we write 300, and in y we write 450. Let a temperature is represented as Tk in Kelvin, Tx in x and Ty in y. Now, let us try to obtain the relation between k and x. Then, from product of means is equal to product of extremes, we have got Tx into 273.16 is equals to Tk into 300, which is one of the equation here. In the same manner, we will try to have the relation between k and y by using the same relation. What we have is Ty into 273.16 is equals to Tk into 450. Like that, we are having two number of equations. Dividing one by the other, we get Tx by Ty is equals to 300 by 450, and 152s and 153s we get the cancellation here. So, we are having Tx by Ty is equals to 2 by 3, and from which we have Tx is equal to 2 Ty by 3, which is our second option. Now, let us try to understand a problem on faulty thermometer. Imagine that mana TV program people have designed a thermometer with melting point of ice as 30 degree mana and boiling point of water as 230 degree mana. What is the corresponding temperature on mana scale if Celsius scale reading is 60 degrees Celsius? Just now we completed a formula like reading minus lower fixed point divided by upper fixed point minus lower fixed point is equals to C by 100, and reading is taken as R, lower fixed point is 30, upper fixed point is given as 230. Just substituting the values here, we get R minus 30 by 230 minus 30 is equals to C value is given as, the Celsius value is given as 60. So, 60 by 100 here on substituting, we are having R minus 30 by 200 is equals to 60 by 100, and R minus 30 is equals to 60 into 200 by 100, 100 ones and 100 twos, 2 into 60 is 120, shift 30 that side. What we are getting here is R equals to 120 plus 30, and 120 plus 30 is 150 degree mana. Okay. So, the corresponding temperature of 60 degrees Celsius is 150 degree mana. Okay. After looking into the temperature and temperature models, now let us try to enter into the expansion of solids. Okay, fine. In the case of solids, when solid is increased in temperature, it undergoes change in its length, in area and also in volume. Okay. Let us consider a metallic rod of length L1 at temperature T1 degree Celsius. When temperature is increased to T2 degree Celsius, its length changes to L2. So, here L1 is initial length and T1 is initial temperature. When temperature is changed to T2 degree Celsius, we are having increase in length as L2. Okay. Now, change in length is proportional to initial length. It is also proportional to change in temperature. So, change in length is given as delta L equal to L2 minus L1. So, L2 minus L1 is proportional to initial length L1. It is also proportional to change in temperature T2 minus T1. Combining these two, we are having L2 minus L1 proportional to L1 into T2 minus T1. Bring the constant is taken as k and k is given as alpha. Therefore, we get the equation as L2 minus L1 equals to alpha L1 into T2 minus T1, and alpha is given as L2 minus L1 by L1 into T2 minus T1 per degree Celsius. It is defined as the change in length per unit length for 1 degree Celsius rise in temperature. We call it as coefficient of linear expansion, and we have denoted it by alpha, and alpha is given as L2 minus L1 by L1 into T2 minus T1 per degree Celsius. After completing coefficient of linear expansion, let us try to understand regarding coefficient of areal and volume expansion. In the case of coefficient of areal or superficial expansion, what we have got is the change in area per unit area for 1 degree Celsius rise in temperature is nothing but called as coefficient of areal or superficial expansion. It is given as beta, and beta equals to A2 minus A1 by A1 into T2 minus T1 per degree Celsius. Okay, fine. From there onwards, what we have got is coefficient of cubical or volume expansion. What it says is the change in volume per unit volume for 1 degree Celsius rise in temperature is nothing but called as coefficient of cubical or volume expansion. It is denoted by gamma and is given as gamma equals to V2 minus V1 by V1 into T2 minus T1 per degree Celsius. The relation between alpha, beta and gamma. Here we know that beta is given as 2 alpha and gamma is given as 3 alpha. So, gamma equals to, we can write as alpha plus 2 alpha, where 2 alpha can be given as beta. So, we have gamma equals to alpha plus beta. Apart from that, if we consider the ratio of alpha, beta and gamma, we have alpha is to beta is to gamma equals to alpha is to, for beta we write 2 alpha, for gamma we write 3 alpha. So, alpha is to 2 alpha is to 3 alpha, which is given as 1 is to 2 is to 3. And in the similar manner, we can have alpha by 1 equals to beta by 2 equals to gamma by 3. Now, let us consider a model on coefficient of linear expansion. Okay, fine. Now, here a metallic rod has a length 100 centimeters at 20 degrees Celsius. The temperature at which it is shortened by 1 millimeter is, okay, fine. The options given for us are, first option is given as minus 10 degrees Celsius, second is given as minus 20 degrees Celsius, third one is given as minus 30 degrees Celsius, and the fourth one is given as minus 40 degree Celsius. Okay, fine. Here the alpha value is given as 2 into 10 to the power of minus 5 per degree Celsius. Now, let us have the conversion of units at first. Metallic rod is having length 100 centimeters. So, L1 is given as 100 centimeters. It is taken as 1 meter. Okay. And next, what we have got is Shortened by length. Shortened by length is taken as delta L, the change in length, that is nothing but L2 minus L1. It is given as 1 millimeter. This will be written as 1 into 10 to the power of minus 3 meters. Okay. And initial temperature is 20 degrees Celsius. Final temperature we have to find. The formula is given as alpha equals to delta L by L into T2 minus T1. Substitute all the values in this. What we have got is alpha is written as 2 into 10 to the power of minus 5 degrees Celsius, minus 5 per degree Celsius equals to delta L is given as 1 into 10 to the power of minus 3 divided by initial length is given as 1 meter and change in temperature T2 minus T1 is written as 20. Okay. On simplifying this complete equation part, we have T2 is equals to minus 30 degrees Celsius. Now let us take another model here. The volume of metal block change by 0.12% when it is heated through a temperature of 20 degrees Celsius. Then the coefficient of linear expansion is given as, okay, the options given are 2 into 10 to the power of minus 5 per degree Celsius, 3 into 10 to the power of minus 5 per degree Celsius and 4 into 10 to the power of minus 5 per degree Celsius, and last one is 5 into 10 to the power of minus 5 per degree Celsius. Okay, fine. Here we are given volume of metal block change by 0.12%. Means, let us say change in volume is delta V equals to 0.12% of the initial volume. It is given as 0.12 by 100 into V. Therefore, delta V by V is equals to 0.12 by 100. But the gamma is given as change in volume delta V by V into T2 minus T1. We are given T2 minus T1 as 20 degrees Celsius. So, gamma equals to delta V by V I can write as 0.12 into 10 to the power of minus 2 divided by change in temperature I can write it as 20. Okay, and we have got gamma as 3 alpha. 3 alpha is equals to 12 into 10 to the power of minus 4 by 20. So, alpha equals to 4 by 20 into 10 to the power of minus 4. Therefore, alpha is given as 1 by 5. 1 by 5 is 0.2. 0.2 into 10 to the power of minus 4, nothing but 2 into 10 to the power of minus 5 per degree Celsius. So, our option will be the first one. Now, let us take another model here. Okay. What should be the length of steel and copper rods at 0 degrees Celsius, so that length of steel rod is 5 centimeters longer than copper rod at all temperatures. And we are given the values of coefficient of linear expansion of copper and steel. The coefficient of linear expansion of copper is 1.7 into 10 to the power of minus 5 per degree Celsius, and that of steel is 1 into 10 to the power of minus 5 per degree Celsius. The options given are 3.14 centimeter, 8.14 centimeter, 6.14 centimeter, 11.14 centimeter, 7.14 centimeter, 12.14 centimeter, and the last one is 8.14 centimeter and 13.14 centimeter. Now, we know very well that coefficient of linear expansion alpha equals to L2 minus L1 by L1 into T2 minus T1. This can be written as alpha equals to L2 minus L1 is taken as expansion E, L1 is taken as initial length L, T2 minus T1 is taken as delta T. Now, from this equation we are having E is equals to L alpha delta theta. E is equals to L alpha delta T. Okay, fine. Now, whenever we say expansion and change in temperature are constant, whenever we say expansion and change in temperature constant, then we have got L alpha equals to constant, from which we can write as L1 alpha 1 is equals to L2 alpha 2. Okay. Next, from here onwards, it is given very clearly that L2 minus L1 is some x value given for us. L2 minus L1 is given some x value. Okay. And now what we do is, to find L1 value, we substitute L2 is equals to L1 alpha 1 by alpha 2. Okay. What we are doing here is, instead of L2 we are writing L1 alpha 1 by alpha 2 minus L1 is equals to x, and L1 is equals to alpha 2x by alpha 1 minus alpha 2. Similarly, for L2 we have got alpha 1x by alpha 1 minus alpha 2. Let us say alpha 1 as 1.7 into 10 to the power of minus 5 and alpha 2 as 1 into 10 to the power of minus 5 and x value as 5 centimeters. Then what we have got is L1 equals to, okay, alpha 2, that is 1 into 10 to the power of minus 5 into 5 divided by 1.7 into 10 to the power of minus 5 minus 1 into 10 to the power of minus 5. Similarly, L2 is given as 1.7 into 10 to the power of minus 5 into 5 divided by 1.7 into 10 to the power of minus 5 minus 1 into 10 to the power of minus 5. On simplifying both of them, we have the value as 7.14 centimeters and 12.14 centimeters. Now let us take another model. Okay, the model, it says in this manner: a uniform pressure P is exerted on all sides of a solid cube at 1 degree Celsius. By what amount should the temperature of the cube be raised in order to bring its volume back to the value it had before the pressure was applied? And we are given the bulk modulus as K and coefficient of linear expansion as alpha. The options given are P by K alpha, P by 2K alpha, third option is P by 3K alpha, and fourth one is 3P by K alpha. Okay. This problem is a link between expansion of solids and also the mechanical properties of solids. Actually, in this case, what we have is, the bulk modulus is defined as K is equals to bulk stress by bulk strain. Here, bulk stress is in the form of pressure and the bulk strain is in the form of change in volume per unit volume. Okay. So, we are given K is equals to P by minus delta V by V. This implies, okay, P is equals to K into minus delta V by V. And here the change in volume per unit volume can be substituted as gamma into delta T. So, we have got K is equals to P by gamma delta T. Put gamma is equals to 3 alpha delta T. So, we are having P by 3 alpha delta T as the K value. Therefore, the delta T can be given as P by 3 alpha K, which is our third option. Now, let us take another model. In the case of expansion of solids, the model is: a clock with iron pendulum keeps correct time at 20 degrees Celsius. If gamma of iron is 36 into 10 to the power of minus 6 per degree Celsius and the temperature of the room is 40 degree Celsius, the clock will lose or gain dash seconds per day. The given options are 10.368 seconds, 5.368 seconds, 20.73 seconds, 33.14 seconds, 104 seconds. Okay. Now, this is a problem which is linked with the oscillations and the expansion of solids. From the time period of simple pendulum, we have got t equals to 2 pi root L by g. For a given place, acceleration due to gravity remains constant and the 2 pi is already constant. So, we are having the time period is proportional to square root of length. This we can write as T2 by T1 is equals to square root of L2 by L1. We know very well that alpha is equals to L2 minus L1 by L1 into T2 minus T1, which I can write as L2 equals to L1 into 1 plus alpha delta T. On substituting the value of L2 in this case, we have T2 by T1 is equals to square root of L1 into 1 plus alpha delta T divided by L1. So that T2 by T1 is equals to square root of 1 plus alpha delta T, which is nothing but T2 by T1 is equals to 1 plus alpha delta T whole to the power of half. Expanding it binomially, we have got T2 by T1 is equals to 1 plus half alpha delta T. So that T2 is equals to T1 plus half alpha delta T into T1, from which we have got T2 minus T1, which we call it as gain or loss in time, is equals to half alpha delta T T1. And now, in the place of alpha, we write gamma by 3 because we are given the gamma value there for iron, okay, and into delta T, and this time for one particular day is given as 86,400 seconds. Substituting all the values, we have half into the gamma value is 36 into 10 to the power of minus 6 by 3, and increase in temperature. Here room temperature is 40 and correct temperature is 20. So, 40 minus 20 is 20 into 86,400 seconds. On simplifying this part, we have the value as 10.368 seconds. Now, let us try to have another model here. If I is the moment of inertia of a disk about an axis passing through its center, the change in moment of inertia due to a small change in its temperature delta T is given alpha as a coefficient of linear expansion. Here the disk is a circular one, a circular disk it is, okay, fine. The options given are I alpha delta T, second option is given as 2I alpha delta T, and third option is given as 3I alpha delta T, and fourth option is given as 4I alpha delta T, okay, fine. Now, we are given a circular disk, okay. The moment of inertia of a circular disk is given as I equals to mr square by 2 about an axis passing through the center and perpendicular to its plane. Now, here the mass of the disk remains constant, okay. Let the temperature is changed. When temperature is changed by delta T, there may be a change in the radius of circular disk. When radius of circular disk changes, the moment of inertia of circular disk also changes. So, we are having I proportional to r square. So, we have got of fractional changes as delta I by I is equals to 2 into delta R by R. But we are having alpha is equals to L2 minus L1 by L1 into delta T. Here L2 can be taken as 2 pi R2, L1 is taken as 2 pi R1 divided by 2 pi R1 into delta T. So alpha is equals to R2 minus R1 by R1 into delta T, implies alpha equal to delta R by R delta T, so that delta R by R is given as alpha delta T. Substituting the value of delta R by R as alpha delta T in this equation, we are having delta I by I as 2 into alpha delta T. Then change in moment of inertia is given as delta I is equals to 2I alpha delta T. And 2I alpha delta T is our second option. Therefore, answer 2 is correct. Let us have another model right now. The model is the force which must be exerted to prevent a uniform rod of cross section of area 2 millimeter square from expanding when it is heated from 5 degrees Celsius to 25 degrees Celsius is, okay, and you are given the alpha value as 12 into 10 to the power of minus 6 per degree Celsius, and Young's modulus is given as y equals to 10 to the power of 11 Newton per meter square. The options are first one 18 newtons, second one 28 newtons, third one 38 newtons, and the fourth one is 48 newtons. This is a model which is having a link between expansion of solids and the mechanical properties of solids. From the mechanical properties of solids, we have the Young's modulus as longitudinal stress by longitudinal strain. Implies y equals to longitudinal stress is F by A, longitudinal strain is change in length per unit length delta L by L. So that we are having y equals to F by A divided by the change in length per unit length can be written as alpha delta theta, where delta theta is change in temperature. This can be given as y equal to F by A alpha delta theta. Okay, from here we are having F is equals to YA alpha delta theta, where F is called as thermal force. The value of F is known as thermal force, and thermal force is given as YA alpha delta theta. In our problem, he is asking that thermal force itself, and we are given the Y value as 10 to the power of 11 Newton per meter square. Area is given as 2 millimeter square. Convert millimeter square into meter square, like 2 into 10 to the power of minus 6 meter square it is. And we are having change in temperature as 25 minus 5 as 20 degrees Celsius, where alpha is given as 12 into 10 to the power of minus 6. Substituting all these values in the given formula, we have F is equals to Y is 10 to the power of 11, area of cross section is 2 into 10 to the power of minus 6, alpha is given as 12 into 10 to the power of minus 6, and delta theta is given as 20. Okay. On simplifying, we are having the value as 48 newtons. and that is fourth option. Now let us try to understand another model here. A bimetallic strip of thickness 2 centimeters consists of zinc and silver riveted together. The approximate radius of curvature of the strip when heated through 50 degrees Celsius will be. We are given alpha of zinc as 32 into 10 to the power of minus 6 per degree Celsius. Alpha of silver is given as 19 into 10 to the power of minus 6 per degree Celsius. And the options given are first one 10.71, second one 20.77, third one is 30.77, fourth one is 40.77. Okay, fine. In this problem, we are coming across regarding the bimetallic strip. Bi in the sense two metallic strips, two different metallic strips kept together is nothing but called as bimetallic strip. It is not simply keeping together, but it is riveted together. One is zinc, other one is silver. Okay. When the temperature of zinc and silver combination is increased, it undergoes a convex type of shape. The one which is having more alpha is above, the one which is having less alpha is below. Okay, fine. Here the upper one is having the length L2, the lower one is having the length L1 right now. Okay. The outer one is having a radius of curvature as R2. And the inner one is having a radius of curvature of R1. The interface between them will have a radius of curvature of R itself. Okay. And the central portion is making an angle of theta. Okay, fine. Here. Now, we know very well that L equals to R theta. As theta is the constant one, we are having theta equals to L by R. And L by R can be written as delta L by delta R. So, theta equals to L2 minus L1 by R2 minus R1. Okay. L2 minus L1 is given as, in this case, here L2 can be written as L1 into 1 plus alpha 1, L into 1 plus alpha 1 delta theta minus L into 1 plus alpha 2 delta theta, and R2 minus R1 is the thickness of the bimetallic strip, which is given as 2T, T for each strip. So, T plus T, 2T it is, implies theta equals to L gets cancel off, plus L minus L gets cancel off, and we are remaining with L into alpha 1 minus alpha 2 delta theta by 2T. Here theta is given as L by R. So, L by R equals to L into alpha 1 minus alpha 2 into delta theta by 2T. So, that L gets cancel off. The inner radius of curvature R is given as 2T by alpha 1 minus alpha 2 into delta theta. The thickness 2T is given as 2 centimeters, 2 divided by alpha 1 minus alpha 2, which is nothing but 32 minus 19 into 10 to the power of 32 minus 19 into 10 to the power of minus 6 into change in temperature. The change in temperature is given as 50. So the final result will be 30.77 centimeters.